So welcome all. Today in this video we will be knowing how to make molar solutions. Okay, like 1 molar solutions, 2 molar solutions, millimolar solutions. How to make those solutions in laboratory we will see in this video. Okay, like any substance are there. That substance, if you know the gram molecular weight, that gram molecular weight, if you dissolve in 1 liter of water or any solvent, it will give the 1 molar concentration. Let's say the example of NaH. NaH molecular weight is 40, correct? Then 40 gram dissolved in 1 liter, it will give the 1 molar concentration. Okay, this is a universal truth. Whatever substances are in the world, we have to see their molecular weight. That much we have to weigh in the grams, like NaH 40, NaH molecular weight is 40, then 40 gram dissolved in 1 liter, it will give the concentration 1 molar. Okay, but in laboratory sometimes we need things in millimolar also. Okay, then we have to take this relation 1 molar is equal to 1000 millimolar. Okay, so question might be like that, then how will you make for 100 millimolar 1 liter NaOH? That is a question. Okay, so whatsoever questions, we have to write the principal statement first. This is the line where I am drawing, that is a principal statement. The principal statement says a gram molecular weight of the substance dissolved in 1 liter, it will give the 1 molar concentration. We have to write always this. Okay, no matter the question is for millimolar, micromolar, whatsoever, we have to write this statement. Okay, then you have to think about the next statement. In that statement we have to write this millimolar. Okay, like 100 millimolar we are going to make. Okay, then you see this principal statement here. Principal statement says a gram molecular weight dissolved in 1 liter gives the 1 molar concentration. Okay, that you have to write always. Below that you have to write your things whatsoever you required. Okay, then we have to divide this 100 millimolar by the principal molar things, like 1 molar. We have to divide this 100 millimolar by the 1 molar. Okay, but unit should be the same. This 1 molar is equal to 1000 millimolar, right? Then 100 millimolar divided by 1000 millimolar, correct? The answer will come 0.1. If you divide 100 millimolar by the 1000 millimolar, answer will come 0.1. This 0.1 we have to multiply to this principal gram, that is a 40. Then answer becomes 4. 40 multiplied by 0.1, answer will be the 4. Then 4 gram dissolved in 1 liter, it will give the concentration 100 millimolar. Correct. So now we understood these things, hopefully. Let's say the next example. The next example is, how will you make 100 millimolar NaOH for 200 ml? This time we have to make for the another volume, that is a 200 ml, not for the 1 liter. 100 millimolar NaOH for 200 ml we have to make. So whatsoever the questions, we have to write always this principal statement, like gram molecular weight dissolved in 1 liter gives the 1 molar concentration. Like let's say NaOH is there, then 40 gram dissolved in 1 liter, it will give the 1 molar concentration. In next line, how this 4 gram came? 4 gram if you take dissolved in 1 liter, it becomes 100 millimolar. How this 4 gram? 1 molar is equal to 1000 millimolar, correct? Okay, this 100 millimolar you have to divide by this 1000, then answer will come 0.1, correct? Like if you divide this 100 by the 1000 millimolar, answer will come 0.1. This 0.1 you have to multiply to this 40, then it becomes 4. Okay, you have to write this. Then 4 gram dissolved in 1 liter, it will give the 100 millimolar concentration. Next line, in this line we are going to calculate for this 200 ml also. Question is here, how to make this 200 ml for 100 millimolar concentration. 200 ml volume, 100 millimolar concentration. So we are going to calculate for the 200 ml 100 millimolar. Okay, so this time we are going to consider for this 200 ml also. Okay, simply what we have to do is here, this 200 ml is there, no, we have to divide this 200 ml by the principal ml. Principal ml is 1 liter, means 1000 ml. Okay, that 1000 ml you have to divide to this 200. Okay, then 200 divided by 1000. Okay, 1000 ml. What will be the answer? For this purpose it will become the 0.2. Correct. Will you give the answer? 0.2. So this 0.2 we have to multiply to this 4. Okay, then 0.2 multiplied by 4, what will be the answer? Answer will be the 0.8. Correct. Here I written wrong. That's 0.44. It is a 0.8 will become the answer. Okay, that means 0.8 gram if you take dissolved in 200 ml, it will give the concentration 100 millimolar. Okay, so this is a very lengthy calculation, right? We need some shortcuts. Okay, for this question, same questions I'm repeating in shortcut manner. Okay, like NH you are going to make NH only for the 200 ml and 100 millimolar concentration. This I am going to calculate in very shortcut manner. Suppose if you want to calculate how much gram required to make 200 ml and 100 millimolar concentration of NaOH, you just have to write the NH, like whatever substance you are going to make, that molecular weight you have to write, and you have to multiply by how much volume you have to require. That's 200, no? But while multiplying, you have to shift the decimal points toward the left. This left. Then if you shift a decimal point toward the left, how much time you have to shift? 3 times you have to shift. Then if you shift the decimal points 3 times toward the left, then 200 becomes 0.2. 0.2. Then that is for only volume things. Next thing is for, we have to do same thing by taking account of the millimolarity also. For millimolarities, this is a 100 millimolar. For this also, we have to write in the multiplication with this molecular weight, but 3 times decimal point we have to shift toward the left. Then this 100 becomes, this 100 if you shift the decimal point toward the left, this 100 becomes what? This 100 become 0.1 then, correct? Correct? 0.1. Then molecular weight multiplied by this 200 ml, that is written in the 0.2 by shifting 3 decimal point. Then 100 millimolar, that is written as a 0.1 by shifting 3 decimal point. Why we are shifting decimal point 3 times here? Because we are converting this 200 ml into the liter form. Like 200 ml, we are just saying that this is a 0.2 liter. This 100 millimolar we are just writing as a 0.1 molar, because 100 millimolar is equal to 0.1 molar. Those things only we are multiplying to the molecular weight. Then it will give the answer 0.8. That means 0.8 gram if you take and dissolve in 1 liter. Dissolve in 100, this 200 ml. Sorry. Dissolve in 200 ml, it will give the concentration 100 millimolar. The wholesome meaning of these things. So this is a shortcut, correct? But we are moving 3 decimal point toward the left for the volume purpose also, for the molarity purpose also, for this millimolarity purpose. But if things they are telling, the calculations, the questions they are telling like molar and liters, that time we do not have to shift the decimal points. Let's take the example. Like example is NaOH, we are going to make for 2 molar and 1 liter. If questions are in molar or liter, you do not have to shift the